Welcome to CPP Chat, the second podcast for C++ developers by C++ developers. Before we continue, I want to read this week's disclaimer. In the unlikely occurrence that any of our public events have to be canceled or postponed due to circumstances beyond the control of CPP Chat, we cannot be held responsible for any costs incurred by the event attendee. There may be show photographer present at our event, and by attending, you give us permission to use any general crowd photos you appear in on our website or for marketing purposes. So, with me today is my fellow host and the show's producer, Phil Nash. Phil, do you have any personal CPP Con related news you want to share with us?
CPP Con. Nothing interesting's happened there recently, has it?
Oh, I don't know. You tell me.
Well, after a marathon week of your review committee or core team, crack team, deciding on the final schedule, it emerged that I had 1.5 talks accepted. So thank you for that. The half is because I'm doing one joint with Simon Brand. I also have
it's not that it was half accepted. It was that it was a joint talk.
Yes.
Yes, I got the impression by looking at the CPP Con chat group that everyone was hitting their mail buttons about every 30 seconds to see if we'd sent out announcements yet. That's a little nerve-wracking for us as well, because we really are working as fast as we can to come up with the list, right? In addition, joining this week is Jonathan Boccara. Jonathan is the author of the Fluent C++ blog, and his talk, 105 STL algorithms in less than an hour, has also been accepted as part of this year's CPP Cond program. Jonathan, are you excited to be speaking at CPP Cond?
Oh, absolutely, yeah. That'll be my first talk at CPP Cond. And,
not your first conference talk?
No, not my first conference talk, no. And yeah, I'm excited about the topic, about talking about the STL algorithm, which are a fantastic, fascinating topic. And yeah, we'll try to get them all done in an hour so that we actually learn them and once and for all, hopefully.
Well, I have had people, quite a few people actually come to me and say that after listening to Sean's talk, suddenly realized that they didn't know the algorithms as well as they should. They didn't know, sometimes you can't tell from the name, like rotate. What the heck does that actually do? Does that spin all my integers? I don't know what that means, right?
Yeah.
And so you're going to have a chance to set people straight on that.
Right.
So also joining us this week is Kate Gregory. Kate is well known in our community as an author and speaker. Kate's talk, "What do you mean when we say nothing at all?" has just been accepted as part of the main program. And her talk, "Simplicity, Not Just for Beginners," is going to be a keynote. And as part of the agreement to be a keynote, she has agreed to be on CPP Chat as well. It was kind of, one of those riders on the contract. You can't be a keynote unless you come and join us on the show, and we're going to beat you up on the show, right? So have you regretted that, Kate?
I regret nothing, Jenny. Regrettably, no, I'm good.
Well, this is not your first time at CPP Con, or not your first time speaking at CPP Con.
No, everyone except the year I was too sick, but my first keynote, so I'm pretty excited. Yes, yeah. And I have to lengthen my talk.
Why adding more stuff couldn't possibly compromise simplicity, right?
Well, we have been known to add more stuff to make it simpler. That'll be okay. But actually, my main problem with that talk in the past has been managing to fit it into an hour. So the idea to kind of stretch my wings a little bit and be more opinionated, that works for me.
Yeah. And this is a point that I've often made about the challenge that the standards committee has, is that everyone recognizes that one of the biggest problems with C++, it is so complicated, but the committee can't take things away because then they break code. So the committee has to think about clever ways to add things that simplify. And I think they have a pretty good track record of having done exactly that. They add things like, range-based for loops or auto or something like that, which actually makes the language simpler and easier to use, even though the number of pages in the in the standard goes up. But I think that's adding things to make things simpler is a challenge, and that's what the committee's faced with doing. So
yeah, that's their role they're stuck with.
So I think we're going to talk some about simplicity, but before we get there, I think we've got some stuff going on we should talk about for people who haven't watched it or listened to it yet. I should say the CPP Cast guest this week is Michael Case, and of course I've been teasing him and giving him a lot of grief about being on that show, and he hasn't been on this show in many months, but but I'm glad he got to be on that show. I thought it was a great interview. I thought it went really well. And he talked about several things that are important to him, and talked a little bit about embedded, which I know is I think a very interesting area for C++ because we're so underutilized. There's so much stuff you could do in embedded better by using C++ rather than C, and it's just not well appreciated. So I thought that was interesting. Let's see. The other thing that has come out this week is Herb's trip report. It was one of the later trip reports, but he said that he deliberately delays his trip reports until after the mailing so that people can, in fact, see links to the papers if they want to. And there was one of the big things that he highlighted. In fact, the big thing, he said that the biggest thing that's gone into the standard so far, the thing that's going to have the most impact on people is what we talked about in our previous episode, which was contracts. And he also links that to something else that we've talked about before, which is static exceptions, or he didn't refer to it as static exceptions, but a new way of doing error handling. And this to me is a huge, huge change. And I said this on the previous show, that if we could fix some of the issues related to exceptions, right now, I think exceptions are the right thing to do in 95% of C++ code. But if you want to write a library that you want to be usable in that other 5%, then you're kind of tied. It's like, well, does my library going to use exceptions or not? And that's a challenge for us. And if we could address that, huge win. And I think Herb is pushing hard to make some of that stuff happen. It's not going to happen by 20. But anyway, so read the trip report if you're interested in that. What else did he talk about? He talked about, this was just one line in there, but I thought it was significant, and that is that there's a statement on standard library compatibility that Titus's group, and if you want to know more about this, then again, CPP Cast had Titus on to talk about this last week. And he was talking about the new library group. All right, I'm sorry.
Study group.
The new study group. Well, actually, that was for tooling. I guess this is not related to the tooling one, but this is Titus's other group, which is the library group, and they've put out a standard document on trying to define what you can and cannot do with the standard library. And I think that's really important because the standard calls things out in a few places, but it's not pulled together. So it just says, well, you can't add this to the standard, to the STD namespace and things like that, and you can't make these assumptions. And I think it would be better if there was a standalone document that says, this is what you can do, this is what you can't do. So I thought that was interesting. Is there anything else in that trip report that I missed that I should have called out? Anything controversial in there?
I have not had a chance to read it yet, so
haven't either.
Herb is being very diplomatic in that, I think.
He missed the opportunity to call the standard, the new error handling Herbceptions, like everyone else is.
Oh, I hadn't heard that yet, but I guess that's well, he didn't really invent them, but he's embraced them and pushing them forward. And I think that's if they happen, I'm willing to call them whatever people want to call them. I like calling them static exceptions, but I'll call them whatever they want to call them if it's done right. There's still opportunities to screw it up, but what I've seen so far, I'm happy about.
I think the combination of contracts and static exceptions will take care of so much of the trouble that we run into, and then you can have predictability, right, in performance. Because for a lot of people, it's not even about fast or slow; it's about knowing when it's going to be fast and when it's going to be slow. So it'll be good.
In fact, if you watch my C++ Now talk, I go into this in some detail. actually weigh up all the different approaches to error handling on a 8-point scale, I think, and show how they just come out with top marks compared to everything else.
Mm-hmm. Yeah. So what else is happening around the world? I guess Pacific C++, the tickets are available, and an official speaker announcement next week. So we have a little bit of a promise coming out there. CPP Cond, a lot of stuff has been happening. I've been crazy in the last couple of weeks. We announced plenaries, maybe a couple of them, not a big surprise, Herb and Bjarne. But two others, also not necessarily huge surprises, but Kate, who has spoken at CPP Cond before and is one of our popular speakers, and Chandler, who is certainly one of our popular speakers, also spoken at CPP Cond before and has been a plenary before, is going to be talking about Spectre. And this is, of course, a completely new topic for us, because I'm not sure when Spectre was originally published, but it wasn't before the last conference. So this is a new area for us. And we haven't had a lot of security stuff at the conference, but that's going to be kind of a mini theme. There's not a lot of sessions on it, but we have some security sessions, and the Spectre talk is actually going to be, Chandler's talk will be followed. He'll get his full plenary talk, but then after that, we're going to have a plenary panel to address to follow up on what is being done. And I'm not going to announce any particular names, but the people who are going to be on the panel with Chandler represent, let's say they represent operating systems that are used by most of us, and so it's being taken very seriously, and Chandler is able to get the right players to be on the panel. And so I'm really excited about that. Chandler will be on the panel, and then Matt has agreed to, Matt Godbolt is going to moderate the panel for us. So it's going to be pretty good. But those weren't big surprises, I think. But their big surprise was the one we announced on Thursday. That's Mark Elmt. I hope I got that name right. And most people in our community haven't heard of him, but he is responsible for a piece of software called Houdini. And again, most people in our community haven't heard of Houdini, but I guarantee you everyone has seen the result of Houdini, because it's a tool used by the movie industry. And Mark said that every movie in the last 10 years that won an Academy Award for visual effects has used Houdini. It's very important in that industry. And when he won the Academy Award, he actually did a call out to WG21, which he actually referred to as WG21, which was like, does anybody actually call it that? I mean, I know people who have been C++ programmers for a very long time, and they wouldn't know what that meant. They would just call it, the ISO committee or the standards committee or something like that. But he called him WG21, and he thanked him for C++ 11. And so this was cool. This was absolutely really cool. And I'm expecting that he'll have some great video clips. But of course, hearing about the performance challenges of software like that, very exciting. And then, so we were releasing those all week. And then we're trying to build to the big deadline, which is actually tomorrow. You have until tomorrow to do early bird registration deadline for CPP Cond. And in fact, we have gotten a huge response. There's been a lot of registrations in the last over the last week, just a huge number of responses, right? And we've still got, if you're watching this live, or if you've still got, until whatever time, midnight tomorrow night, to go ahead and register. And then the announcement yesterday was just a goodie, and that is the video. There's a promo video that we have every year, and I thought this year's was probably the best we've done. And I'm really excited. I should say we done. I don't get any credit for it. It was Mark Basham who does our recording for all of CPP Cond, and also now he does it for C++ Now. And they put out the promo video, which features Kate.
and Matt and a lot of people, actually. I probably recognize 10 people in the video.
Yeah. Yeah.
And lots of happy crowds.
Lots of happy crowds. Yeah, it captures a little bit about the size. There's a lot of people. Yeah, Scott does some of the voice, Matt, as you said. And then there's shots of Herb and Nico and Bjarne signing books and all sorts of stuff. So I'm hoping that it gives some feeling for why it's not just the sessions. It's not just, you can't just sit home and watch the videos and say, oh, why did I need to go? It's same as watching the YouTube videos. It's not quite the same experience.
Definitely. And the venue, you know, like people are out on the balcony or people are milling around looking down at other levels. I think it's makes you feel more connected to other people.
Yeah, clearly, I think that it's true for a lot of conferences. Like going there is actually valuable in itself. That watching videos is interesting, but going there is different, really. And I think people should at least try it once to go somewhere to see how it feels, how different it is from watching videos.
Yeah. Well, the opportunity to speak to the other attendees. I mean, that's what to me, that's what the conference is really about. It's about the people who are getting together.
Yeah. And also, when can you find like 3 or 5 days in a row when you can spend all day watching videos about C++? That doesn't happen.
Right.
And then talking to other people about them.
Right, yeah.
So actually discussing the talk. So it works like both ways. They feed into each other.
Absolutely.
Definitely.
Yeah.
What I think is amazing is we have so many C++ conferences now that I can't go to them all. And, you know, 5 years ago, I probably could have, but not anymore.
Yeah. That is a huge change. Most of them in Europe. We don't have a lot more in the US. We do have a couple in Asia because we have Pacific, and then the one in China, which you were at the one in China. You were the keynote speaker in Beijing.
I was there, C++ Summit, it's called, and I had a very good time. Not just from being in China, but actually just like it was actually a real conference and people asked questions.
Do you remember?
And it was.
Do you remember what the turnout was?
It was hundreds. Yeah. There was other tracks, so I didn't necessarily see all the people all the time. There was like a Chinese tracks and English tracks, where English tracks were still being translated to Chinese. But the attendees were interested. The material was relevant to them. The questions were good. So I was happy to have gone.
Awesome.
Yeah. Plus, that was in China.
Yeah, most of the new conferences are in Europe. There's a lot of regional conferences in Europe and like national conferences that are shorter, 1 or 2 day conferences or something like that. And then there's some bigger ones, including a new one that's coming in February.
That's right. I don't know if anyone's heard about this one, but it's called C++ on C, run by myself, of course. And just to remind everyone, the call for speakers is still open till the end of July, which is only 3.5 weeks away. So now is a great time, now that all the panic over whether you're going to get a talk accepted at CPP Cond is over. Now's a great time to actually get your submission in for C++ on C. So I expect that inbox to be full on Monday morning.
So we did announce we haven't announced publicly, but we've announced back to the individual submitters whether their submissions were accepted or not. We were about 4 days late on that, but there has been a lot of discussion of that. We will, in the very near future, actually have a list of all the sessions. We won't have a schedule because that takes a lot more time to put together, but we will have a list of which sessions are accepted. And the reason we have to have that is because we want people like Jonathan and Kate and Phil to look over that and help us with the schedule by identifying other talks and say, well, that's similar to mine, don't schedule it at the same time. Or, you know, that's kind of good background for mine, schedule that one before mine. So we try as much as possible to put some sanity into the schedule that way. And with the number of talks that we're talking about, and it is over 120 talks, it's really hard to look at every talk and think about all the other talks. The best way to do that is to outsource that to the speakers themselves and let them look at the other talks and say, this is related to mine. It shouldn't be at the same time or whatever. So that list will go up along with a plea out to all the accepted submitters to please look at that and think about their own talk in that context so that they can give us the feedback that says for helping the scheduling. And then there's always the people who can't attend, have to fly in late or have to leave early. And so they, we need to get that information back as well. So that in theory, once we publish the schedule, it doesn't get a lot of tweaking. That's the goal. When the schedule comes out, we don't want to have to make a lot of changes. We want it to be right when it gets out. That's never the actual case, but that's the goal.
So were those notifications really only 4 days late? Felt like an eternity.
Well, I cheated because on Sunday when I realized, well, there's no way, we're not even close. I went into the timeline and I extended the timeline out by another 2 days. So I gave myself till Tuesday. But then on Tuesday night, it was also clear that we weren't going to make it. I said, well, it's fine. It'll at least go out on 4th of July. That's a holiday. It hardly counts as being late. And then when we got to the end of the 4th of July, it was like, oh, there's still a few questions that we have to decide. And so it actually went out sometime during the day on Thursday. And I suppose if you were in England, it was probably closer to the end of the day on Thursday. So it probably felt like an eternity to you.
We're trying to work out which territory was in the time zone furthest west.
I'm sorry to put people through that, but I will say, it's because we weren't doing this casually. We were doing an awful lot of looking at each individual, and we looked most closely at the ones that we were saying no to. Is there any way this, this should be accepted? And in some cases, part of the delay was because we were thinking, could we approach this proposer, this submitter, and ask for a change that would make this closer to what we're looking for? And, we take that sort of thing very seriously because our goal is to make the best possible content for the attendees. And it's not to necessarily reward people for great submissions or something like that. That's not the point. The point is to get the best possible content, and so that's what we're trying to do. And it takes a long time, particularly since you'd think, well, why don't we just start early? Well, keep in mind, all these submissions, I shouldn't say all, but almost all these submissions come in right at the deadline. And it would sure help if people would submit their talks within a week of our announcing the talks, and then we would have a lot more time to look at them and say, this would be a better talk if it was like this, and then we could get back to the submitter. But it doesn't work that way, and so it's still.
But if you're hearing this, you still have a chance to write your ways for CPP Plus on C. Early.
Or if you're excited about having been accepted and you think, gosh, maybe I could do it again, talk to Phil about that as well.
Definitely. I really like the way that we come back now and say, could you change this? Because I think all of us have had something rejected with a note that says, oh, the first half of this would be an hour talk on its own, and I would accept that. But because this person put these other bullets in their outline, I'm rejecting this talk. And it's like a knife, like I can handle, we're not interested in your opinion on that thing because it's not important to anyone. But it's like, oh, like if you'd have asked me, I would have made that change.
Yeah. And I was just mentioning before the show started, I'm thinking about a blog on, so you want to be a conference speaker, to tell people about the best way to get accepted at a conference. And one of the things is submit early. I was joking about everybody submits at the last minute, but that's really true. And submitting early is a good way of, I'm not guaranteeing that when somebody's going to look at it and say, oh, we'd certainly accept this if you change the title and the first 2 bullet points, but that could happen. You could get the kind of feedback that would make it a little more palatable. So there's things I want to talk about and kind of coach people and say, and one of the things I want to say is, that if you compare the quality of the typical / average submission from 2014 to now, the quality has gone way up. And part of that, I think, is because submitters have some experience and they do a better job. But I think it's also because people are watching the videos and seeing what's expected of them. You know, it's kind of like when you see how it's done and you realize, oh, I could do it that way, and you learn what's expected. And so the average quality of the submission has gone way up, and doesn't make it any easier for us. It does in a sense, because we love having high quality submissions, but it means that it used to be that, you know, if people didn't write a very good abstract, it was easy to say, well, you know, but if everybody starts writing better abstracts, well, it's good for everybody, but it also makes it harder for us to distinguish the, you know, the good ones from the really good ones. And so that's part of the challenge. Welcome to this world, Phil. You're going to, you've got some tough decisions ahead of you, I can assure you.
Oh yeah, I'm sure. Well, I think it's going to be a good problem to have.
Yeah, it's nice. I always tell people that, you know, I cry myself to sleep when we do this every year, because it is, I mean, we say no to people who have given good talks before. We say no to stuff that's of an interesting subject area. There just isn't room for everything. And it's just getting, as I say, the bar is getting higher and higher. So we're rejecting better and better talks every year. So it is tough. So let's talk a little bit about simplicity, because this is something that is going to be Kate's keynote, but Phil has also talked about that, and it's kind of one of the themes of Jonathan's blog, right?
Yeah, absolutely.
You want to kick us off, Kate, and tell us about what your keynote's going to be?
Well, the parts I haven't written.
Well, let's focus on the parts you have written. How about that?
Well, how about this? We'll start with the title. You know, when we teach people C++, we often leave all kinds of things out to keep it simple because you're just a beginner. And so we're like, well, we won't do any error checking, and we won't do any this, and we won't do any that, because we're just trying to be simple. And so when I advocate for simplicity, you know, sometimes people think that's what I'm advocating for. And I'm advocating for an entirely different kind of simplicity that has nothing to do with, let's not bother cluttering this thing up with some tests, right? I'm talking about code that is, one word I often like to use is transparent. When you look at it, you know exactly what it does. It couldn't do anything other than what it does. So it doesn't take long to read a 5 or 10 line loop and determine that it's being some kind of sort, or that it's trying to select all the odd entries or whatever. But, you know, when you call a function that's spelled SORT, everybody knows that this is sorting. And when you call a function that's FIND, everybody knows that this is finding. And that's a different kind of simplicity, right? Because it's about being really open and really obvious. And it's actually incredibly hard to do. So I decided I was going to start talking about not only why to do it, which I've been doing for a while, but also how.
What I really liked about, because you've done not exactly the same talk, but a very similar talk already. But I was recently watching the ACCU edition. What I really liked about it was it's very different from my own talk on simplicity.
Yes.
But not in a way that, you know, one of us is right, one of us is wrong, or that we're even talking about completely different things. But you're really picking up the more practical side of things. You know, what you're actually going to do in your real code day to day, specifically, that makes it simpler. Whereas my talk was much more broad strokes, dare I say, even a little bit academic in places, which I think is also important. But I only sort of get down to some of the nuts and bolts towards the end. So I thought that made like a really nice continuum. So that's why I thought it'd be great for us to both discuss this on the show as well.
What I liked about Kate's talk, if I may give my opinion on that too, because I was lucky to actually attend it back at ACCU last year, or this year, is the difference she makes about simple, as in like understandable and elegant, and simple as in I didn't think that through, right? And she explains about where the limit is, and I think that's a very important question.
And
It
in
actually
fact,
requires a fair amount of bravery.
Yeah.
Yeah. But that particular point actually stood out to me as well, because in my talk, I talk about accidental complexity versus inherent complexity. And so you have a certain amount of inherent complexity in any given system or project, and that would include all of the error handling and but those parts we tend to leave out when we're just showing a so-called simple demo. But they really are an important part of a real project. You can't leave them out. What we want to leave out is the accidental complexity, the stuff that's not actually necessary in order to achieve whatever our goal is. So it's two different ways of looking at the same thing.
Is that like when you've over-engineered your logging system, and so you really only need a simple logging system, but you've actually set 6 different levels of loggability, and you have all sorts of different, you've just created all this needless complexity instead of just saying, look, let's just build what we actually need. Is that what you mean by that?
That's definitely a good example of gold plating, which is accidental complexity. But it can be on a much smaller scale as well, just down to a single function. So it's a great example is in Kate's talk, actually, where you just slightly change the way that you write the code, and suddenly the intent drops out. It's just there in front of you. You can't miss it. Whereas before you had to hunt for it in the code, and it might only be a few lines of code difference, but you had to think about it. You had to think about bringing that intent out and making sure that there's no extra cognitive friction in finding it, rather than necessarily extra features as such.
Mm-hmm. And is accidental complexity also happening when you don't really have the big picture, when you try to add something to the code and then you patch up something and it doesn't really fit, and that's
it
accidental?
grows
because,
organically.
Yeah. And it doesn't.
I have a code base that I worked on that once upon a time there was a report. So you would bring up the report, right? And then, it had the usual, you got to set up the headers and set up the footers and blah, blah, and all the stuff you do when you're writing a report. And then they added like a second report. And it was mostly the same. So they just kept the function the same, but then there's like, an if report type equals this for 5 or 10 lines, right? Well, then you know what happens? They add a third report. So now there's a switch. And today, the switch statement is thousands of lines long in a function that is, I think the function is 6,000 or 7,000 lines long. The file's 15,000 lines long. So you'll be on Skype and the guy will be like, so as you can see on line 9,732, and we're all, going to that line number.
How much time did it take to go from the 5-line function to the behemoth in the code?
Decades.
Okay.
Decades. Yeah. And so
that's how long it took to understand it as well.
Well, I honestly did write a 27-step process for how to add a new report. It's a simple 27-step procedure. It's just like so awful. And so how do you fix that? If it had all been virtual functions, life would be so much better, but it's not. And there's all these switch statements. There are functions called like, can sort, let's say, and there's a switch. And it's like case, half the report numbers return true, and then the other half of the report numbers return false.
Wow.
And like, I don't know when they should have made the switch. Maybe 10 reports. Like it was probably okay when they were at 2 or 3, but they probably should have made the switch at about 10. But like it's your job to add the 11th report today. Are you going to re-architect everything? Or are you going to add the 11th report so you can go home, right? And
well, part of that is a cultural question, because is your culture that we get the code right, or is it your culture that we get the code done? And if you know that you're expected to get the 11th report done by the end of this afternoon, then that's what you're going to do. But if you can say to your manager or to the rest of the team, look, I'm gonna take the bullet here and re-architect the report mechanism, because we're clearly going to have more reports and it's going to be worth it in the long run. that's a cultural issue, right? It's not a technical issue because, as you said, when was the right time to make the change? Well, in a sense, from a technical point of view, it doesn't matter. The real question is, when was the cultural time? When was it that people would say, yeah, let's bite the bullet, because it's more important to get the code right than it is to get it, as I said, done.
And a lot of this code was written at a time when we did not know how long our code was going to live. You know, like the reason there was a Y2K problem was that in the 70s and 80s, we didn't think our code would last until the year 2000. And,
that's 20 years away. Are you crazy?
Exactly. That's not going to happen. And so this is like an MFC app. I don't know when it was born, probably in the 80s or 90s, you know, and it's a very good app. It makes a lot of people a lot of money. And I don't think it was written to last as long as it has lasted. So we will never learn the lesson of, please make it so it can last 30 years. But we can always try to keep teaching it anyway.
There's an interesting tension here, though, because you also don't want to overgeneralize or try to make things too robust against future decisions too early. The trick is more to keep the code sort of malleable and, dare I say, agile.
Yes.
Which is really the whole point.
Yeah, I'm somewhat of a victim of that. I'm the one who's going to sit down there and write a logging system that has 8 different levels of logging. That's just, you know, well, in the future, you might need that. Well, I guess the brilliance is to try to come up with an interface that is modifiable in an easy way, but not try to do all that modification right now.
About that sort of features that grow exponentially, like that switch that grows so much. I think there's a reality check to make in some cases, because if you have one such function, then yeah, you can have a culture about making code right to make future things easier. But if you've got like 20 of them and you need to do bug fixes in all of them, there's just no way in some cases that you can fix them all. And then you have to pick your battles, and some of those big switches just going to patch up an 11th case and be done with it, because there's only 24 hours in a day, you know.
Well, I did, I think, fix this report problem, but the switch remains. What I did was I made it different for new reports going forward. So the old reports are tested and accepted. Everyone's happy with them. And I'm not going to go in and try to change all that and try to copy and paste all that code out. Especially since, as you know, with the scope, right, if you want to use a variable inside a switch, it's usually declared before it. And so honestly, pulling anything out of the middle of a switch is generally very painful. So that all stays. But, you know, we're going to do it different going forward. And if you end up dropping certain reports out of the product, then we can strip out the code, and someday will be nicer. Other times, you get the chance to do it all over again when you're doing a port. So there was another product I was involved with, which is an MFC app, and they didn't want an MFC app anymore, but they wanted all their C++ logic. And so we built a WPF front end and a pure C++ back end, and all of the old code ended up in the back end. And it got a lot simpler because we only kept the parts, you know, that were directly useful to making the calculations. So, you know, the big ports still do happen, and that is a good chance to throw away a lot of garbage.
I worked on a very old app where they had a new hire who came in and was trying to understand the graphics code. And it was actually it's hard to imagine, the app would generate reports and things like that. So when we say graphics, they were not like game graphics or something like that. They were instead the kinds of graphics you might expect in an enhanced reports. And because of the nature of this, they had been added on a little bit here. Oh, we're going to add this. We're going to add this. We're going to add this. And so the design was, the word design shouldn't really be applied to it. It's kind of generous to even say it had a design. And so he went through and rewrote all of it. And he was so pleased with himself. He made sure everybody knew that his net productivity that week was negative 10,000 lines of code or something like that, because it cleaned everything up so much. And one of a couple of bugs came out, but because it wasn't clear what was meant by certain things. What is a double overline? He didn't understand what a double overline was. Well, it turns out when you're totaling a list of numbers in an accounting format, you will double underline something, but right before a total. But the problem is you don't necessarily know if it's a database extract, which is this would be. You won't necessarily know what the last item that you're totaling up is. So you can't say that it's a double underline. Instead, you pick the value below the total and you say this is going to be double overlined. And that's what that meant. But it wasn't at all clear. There was no comments in the code or anything like that. And so what he did was he essentially did the equivalent of an overline except higher up, which is not what you need. You want really the whole cell double underlined. It was an easy bug to fix, but I just thought it was funny because that bug got reported and it was like, what is this? Well, it's because he completely rewrote the code, and it was really was a huge win. It was a little faster. Performance wasn't the main thing. It was just much easier to maintain after that because it finally had a design. But somebody, again, the reason he got away with it was in part because he was a fairly senior engineer, but he was a new hire on the team, so he didn't have any real responsibilities yet. And so he was given some bugs. Can you fix some of this bugs in the graphic stuff? And he looked at that and said, screw this, I'm going to rewrite the whole thing. And, as I said, it was something that people who'd been there had just kind of lived with and knew, well, yeah, it's the graphics logic. But he was basically going to say, no, this isn't acceptable. And he took, I don't know, it took him better part of a week probably, but as a new hire, nobody really cared what he was working on. So, right. So he did it. And it was a great way of introducing himself to the team, saying, well, you can count on me writing negative 10,000 lines of code if you want.
In my team, what we do sometimes is that when we find a piece of code that slows us down for any reason, like it's too complicated or whatever, we put a cross next to it. And then if someone else passes by that same places and has the same problem, he puts another cross and so on. So some places get a lot of crosses. And then when we decide to do some cleaning, we pick the ones that are the most annoying for most people, so that we know we can't fix everything because we have to move on, but we know where the hot places are. So I think we have to pick our battles somehow. I mean, that's just a way to do it. I'm sure there are plenty of other ways, but I mean, yeah, you have to be selective to be efficient.
That's an interesting approach. You put that in the comments. You just have a comment that says, I vote that we refactor this one.
Absolutely. And then we've got CI job that passes the code line and brings up everything about those comments.
I like that. I mean, because you definitely only want to work on the hot stuff. If there's a section that no one's been near for a long time, that no one has to read, that no one has to understand, just leave it. But if there's something there where people are constantly going in there, 5 minutes every time, if it happens once a month, is going to add up to enough time for you to fix it.
Yeah, exactly.
It's one of the reasons I don't recommend like mechanical tools, global search and replace or any kind of automated, like, hey, let's change all your loops to ranged fours or what have you, because maybe you don't care about half of those. And let's focus on the half you care about.
I wonder if we actually need to rewind it a little bit, because we seem to have fallen into talking about how to clean up existing code, legacy code, you might say, which is a really important subject, of course. But we need to obviously be going in a particular direction. In the context of simplicity, we sort of need to know what simplicity is first. In other words, if we're starting the code from scratch, what would we be doing?
Yes.
Rather than, as somebody on the chat said, rather than getting rid of the garbage, don't make the garbage in the first place. If we can't do that, then digging ourselves out of the problem is going to be much harder, I think. So maybe we should start from what does simple code look like to begin with? Kate was touching on it a bit earlier. So I just wanted to add one of the points from my talk, which is actually originally from a talk by Rich Hickey. A lot of people have seen that, Simple Made Easy. Highly recommend watching it, where he defines the word simple based on its etymology as being a single braid or a single sort of crossing over, as opposed to complex being many braids. So if you picture things being woven together, it's those interconnections that makes things complex. So in terms of code, when you're looking at any line of code, the number of other parts of the code base you have to keep in mind at the same time in order to understand what it does is the measure of its complexity. If you can reason about that code on its own, it is simple. So striving for simple code by that metric means striving for code you can reason about in relative isolation. And I found that that's really served me well in trying to identify how to make code simpler, or where the inherent complexity actually is.
So it's about coupling.
Techniques. Sorry?
So it measures complexity regarding to coupling then?
Not the copying.
No, he said coupling.
Yeah, coupling.
Coupling, sorry, yes. Coupling, absolutely. But coupling, not necessarily, we often think of coupling between classes, for example. But coupling between any line of code and any other line of code, either at runtime or at compile time. So it's works on several levels.
A similar thing with the idea of only one is, if you have a change, if you have, say, 2 overloads of a function, and then the real world changes, like the sales tax rules change or something, you have to go and change both overloads in order to accommodate that change. But maybe if you had written that function as a template or with a default value for one of its parameters or something, you might be in a position where there's only one function, and therefore you only have to make a change in one place. And that's the sort of thing that saves you from those weird bugs because someone changed 4 of the 5 overloads, and so you can't figure out why the bug is happening. Trying to keep things to only one, whether it's only one change that you have to make or whether it's only one thing that you have to keep in your head, that's what's going to lead you in the correct direction.
Are you, do you think about the particular example of overloads, do you then think that it's better to have default arguments than overloads?
It depends what the difference is between the overloads. So if you have, I don't know, we were talking about sales tax. Maybe the sales tax percentage is a parameter, right? And then you have the special version of the function for the places that you don't charge sales tax to. Well, I think it makes a lot more sense to have a default value of 0 for the sales tax percentage. And people, they actually feel sorry for the computer, but you're wasting its time multiplying by 1 or adding 0 or whatever.
Poor computer.
Suck it up, computer. I'm just gonna do this. So, where that's obvious, right? Now, I don't want it if you have 2 completely unrelated overloads, really, one that goes and looks in the database and one that, I don't know, reads a file. They have nothing in common. You can't just use a default parameter to put their commonality back together. But other than that, where that's the only difference is that there's some variable X that appears in one of the functions and in the other it doesn't. And so by defaulting it to 0 or 1 or what have you, you can have the same code. Yeah, I do prefer that.
All right.
Someone on the chat was just saying about this definition of simplicity. Isn't that just functional programming? No state, no mutation. And in fact, excuse me, the talk that I was referring to earlier, I do actually lead on to that point. But actually, functional programming is just one technique or one approach that will help in this this quest towards simplicity. And I also find that TDD is another really useful technique that that can help us to achieve simpler code, because it allows us to concentrate on one thing at a time, do the thing that works, and then in a separate step actually clean it up and consider all the principles that allow us to decouple things and keep things clean. So
and by TDD, you mean
test-driven development. That there might be a 1 or 2 day course on it after CPP Cond.
Well, here's another really simple example, no pun intended. When you have crummy variable names and then there's a comment that tells you what the variable is, then that's a coupling between the variable and the comment. You have to hold every time you see the weirdly named thing in the loop, you have to remember, oh yeah, that's just the running total. And if the darn thing was called running total, not only could the comment go away, but that cognitive burden of remembering would go away.
Once you have this idea of simplicity or complexity being the interweaving of things that shouldn't be interweaved, you just start to see it everywhere at all sorts of different levels. And another thing I really like from Rich Hickey's talk is he resurrects this old English word complect to specifically take on this meaning of weaving things together that shouldn't be woven together. It's that this accidental complexity that we add. We complicate things unnecessarily, and you can say very precisely, I've complected this thing with this thing. When you have that language available to you, it really opens up lots of opportunities to talk about things where before you just said, oh, there's a code smell, or there's something more vague. I find that really useful.
About functional programming to limit coupling, obviously there's an interest here because it prevents side effects, but I don't think that's a magic silver bullet against coupling, because you can think of a simple example, no pun intended either, where you've got a function that produces a bizarre output, like something a bit crude that has like something you need to know about it, and then another function picks it up and has to know about that weird thing that's in the output. Then there's coupling between those two functions, even though there's no side effect. So functional programming certainly helps, but it's not just a guarantee that you won't have any coupling.
There are no silver bullets. You can quote me on that. I don't think anyone said it before.
No, no one.
No, functional programming is not a panacea. That's why I say it's a really useful technique that does help us to achieve this simplicity in a lot of cases. But it's not the only one, and it's not always going to help us. That's why I brought TDD into it as well. And there are, of course, other techniques, and just general good design principles are what we're aiming for. And in fact, that's what TDD really helps us with. It helps us to stick to those design principles, even though they're actually quite hard to adhere to most of the time. But TDD sort of makes that more obvious to us as we're going.
So is TDD less about how to test your code and more about how to design it?
Absolutely. Yep. Bingo.
Yes.
In fact, some people call it test-driven design.
The other thing I wanted to say is that simpler is not always shorter.
No.
It's, simplicity isn't just about like taking 20 lines of code and turning them into 2 lines of code. A simple
that's called Perl.
can be, yeah, it can be about like that openness or that transparency. So think about certainly what happened to me, and I think it happened to a lot of people when we got lambdas. I started to use algorithm. Now, it's not just because function pointers are pain in the, to declare. It was also that like then you had to give it a name, and then where was it? And it was somewhere else in some other file. And it was really hard to read the names of these predicates. And now when you can stick a little lambda in there as the predicate, it's transparent. If the lambda is like something like, status equals unshipped, I don't need a function for that. And it's actually simpler to have that predicate in there as a lambda. And that's simpler code because I guess to stick to your coupling example, Phil, I'm not coupled over to the definition of the function or what have you.
One of the weird things about lambdas is that that's what it does. It unlocks something that's been in the standard for a long time, which is the STL. And the irony of course, is that it's not giving us anything we couldn't have already done. It's just sugar, right? It's just syntactical sugar for, in fact, it's even explained that way in the standard. It says, here's what this lambda declaration does. It makes a function object of the type that you just specified, which you could go off and do on your own. But the fact that you don't have to name it, which is an important thing, and the fact that it's in context, the contextualness of it is, I think, it is something that makes it really powerful. I know one of the things that Scott Myers recommends about lambdas, he said they should be contextual, but also short and clear. And I've always looked at that and said, unlike other functions where we don't want them to be short and clear. Is that what you're saying, Scott?
About that, I think that some lambdas are good and some should be packed off into functions. And like, how do you know how short it should be or how clear it should be? Like you're saying, everything should be short and clear, but there are lambdas that are definitely not at the right place. So it makes me think about another definition of complexity, another than coupling, which is clearly very true. But there's, I think, another one, which is levels of abstraction. And for me, simplicity comes down to, I mean, a lot of it comes down to respecting levels of abstraction. And by a level of abstraction, I mean something that describes what it does, as opposed to how it does it. Like a lower level would be how to do it. Like you've got a function, like the name of the function is at a certain level, and it calls other functions which are at a lower level of abstraction because that's how you do that first function. And so I think for a given context, like the body of a function, for example, what you want is a consistent level of abstraction. So when you use an STL algorithm and you try to decide whether you should use a lambda or a function pointer or functor or whatever, then the one way to decide to do a lambda or something else is to think about whether the content of the lambda is at the same level of abstraction of what's surrounding the call to the STL algorithm. If it is, then that's fine to have a lambda, even if it's long, even if it's more than one statement or two statements. And on the opposite, if it's at a lower level, then you don't want to see it, even if it's just one return, whatever.
You're saying in that situation, it makes sense to have that be a separate function object that you instantiate.
Yeah,
one that
exactly.
That where the name is telling you, the name is hiding the abstraction for you. So the name is saying, this is what it does. And within the context of the function you're calling it from, that's too low a level of abstraction.
That's the point, because one point of a function is to raise the level of abstraction. And that makes me think of an idea that I heard from Tony Van Eerd, is how many times do you have to see the same piece of code to ship it off to a function? And when he asked me that question, I said, I don't know, like 2 or 3. And his opinion is just 1. If you see that one time and that's a unit and that's sitting there, then you should pack it off somewhere to a function. And that really show that a function is about raising abstraction, because you replace a chunk of code, even if it's small, by a name which describes what it represents. So yeah, when you're doing an STL algorithm, if your predicate or whatever function you're sending to the algorithm doesn't show what it does with its body, then you should replace it with a name and refrain from using an anonymous lambda. Now, it doesn't prevent you from using a lambda at all, because you can make a separate function with a name that returns a lambda, so that you don't have to go to the trouble of writing a class with a public and private and a constructor and all that kind of things we used to do in C++ 98.
So I have done that. I had some examples where the predicate is, these are literally like vectors of integers. And so the predicate was just checking to see if they were odd or not.
Mm-hmm.
And you can just make a local variable like auto is odd equals the lambda, and then
Just
pass that.
Yeah.
Just as a reason to give it a name. If people don't, it depends who your audience is. You know, in some audiences, when they see you're doing, mod 2, and you're comparing it to 0 or what have you, and then there's the whole, if you can say is equal to 1, it messes up on negative numbers. They get caught up in that, and they forget about the first half of the line of the code, your find if. 1,000 years ago in another life, I was teaching D-based programming, I think it was. And the example was, we're going to give everyone a 10% raise. So we're going to take their salaries, multiply them by 1.1, and then save them back. And half the class was like, why are you multiplying by 1.1? What does that got to do with a 10% raise? And we had to go do 15 minutes on percentages.
Right.
But, that audience was not mathematically literate. These were people who were being retrained as programmers from like ditch diggers and things, and this was something no one had ever taught them before. And so I think it's obvious that we're doing the mod 2 to figure out if it's odd or not. But if that's not obvious, then yeah, you should stick it in a thing with a name, because then you've explained it.
So I think one of the things about C++ is that it allows us to add levels of abstractions without paying for it at runtime, and that's not true of all languages. For some languages, if you said, well, I'm going to break up this function into a whole series of functions that call each other, people might say, yeah, but this is in a performance area, and,
Right.
and all those function calls are not doing us any good. Whereas in the C++ world, we'd say, who cares? The compiler's going to roll this all together, assuming we make them inline and all the kinds of things that we can do. But
const expr.
Const expr, that's right. And I think that's one of the things is getting the levels of abstraction right. And in fact, when I fall into the trap of gold plating, it's probably because I'm getting too many levels of abstraction, and I'm saying, well, let's abstract away that sales tax is calculated, because it might not be just multiplied by a factor. It may be that there's a range where up until $100 there's one factor, and isn't it? So let's make a whole, let's over engineer a whole way of how we're going to calculate the sales tax, when in fact, just multiplying by a fixed amount is almost certainly going to be safe. But that's the way, because I can think about that, and if I can think about it, then I can wrap code around it and make it more complicated.
but it's always judgment, so if something is overdue, because its due date is before now, do I need a function called is overdue, or can I just compare the due date to now? Well, part of that comes from, again, what you expect other people to know, but also how did you figure out the due date? Is it a property or a function you're calling with the name due date, or is it something harder to understand?
Or is it
maybe
possible that it's not overdue if that falls on the Friday before a weekend, and so it's not overdue until Monday? That's
exactly,
how
right?
the IRS works that way, right?
Right. And so suddenly, we probably should have a function called is overdue, and now it needs to know not just about the day of the week, but about holidays, and that's going to be read out of some persistent store, and that's again back to what we talked about at the very beginning, that organic complexity that kind of grows. Looking up holidays in the database, and it's still all sitting in one place, and it should have moved to a function.
Yeah, and that's a tough choice, really, because that sort of comparison can really pop up everywhere in code. So if from day one you decide not to go for the abstraction, then if you do decide to go for it later, then it's going to be a pain, because it's going to be everywhere.
Really hard to search for. Yes.
And how to search for, absolutely, yeah. But yeah, it's a tough choice.
Well, there's some value to experience.
Yeah.
Those of us with gray hair want to believe that.
Again, though, not a panacea, but this is where I find that TDD really helps, particularly because you do end up with that body of tests that are testing pretty much all of your code. When you do come to make these changes later, the tests are going to, first of all, give you the confidence that making those changes is not going to break anything too much. But they'll also tell you where you have broken things because of the change itself, as in you've changed an interface that you hadn't quite pinned down. That's going to break some tests somewhere, and then you think, this is an interface, so I need to make that a bit more concrete.
The other thing I like about that strategy, Phil, is if you can't come up with the tests yourself, if you need the test cases to come from a business person, that's when they reveal the unwritten rule. So they told you before, this is what you do when things are overdue, but they didn't really tell you the definition of overdue, and you thought you knew what it meant. But then when you ask them for examples, they start giving you these Friday afternoon examples that are not overdue yet. And you're like, oh, wait a minute. Turns out life is more complicated, but they would never have told you because everybody knows, right?
We're getting a bit off into testing, which I want to make into a different episode. But what you're talking about is more the domain of BDD, behavior-driven development, where it is more about the conversations with the non-technical people, and absolutely, it's that really opens up those observations.
Well, unfortunately, we can't go off into either direction at this point, because I think we've just blown through. I mean, I was just listening to you guys discuss this, and I think I could continue to listen to that for a long time. I wish that was an option for us. Instead, we'll just have to make a codicil of the arrangement that we made with Kate, which said that, oh, did we say you had to come back on one show? No. We'll have to have Jonathan and Kate back sometime. And maybe we will have them back to talk about testing as opposed to just simplicity. Or maybe, I mean, when we talk about code design, there's about, a lot of different ways of looking at it. and they all kind of maybe they're all complected together. They all kind of overlap, whether you're talking about things like, you know, how it's designed, or the reliability, or simplicity, or, you know, all of these things impinge on each other. But I've cut everybody off. I don't want to. Does anybody have anything last that just had to fit in there before we wish everybody safe coding?
Not one thing, probably 1,000 things. So I'm not going to pick one now.
You're making it too complex. I think the simple thing to do now would be to take the opportunity to finish the show.
All right, we'll do that then, and I'll encourage you to join me in wishing all of our listeners safe coding. So everybody, until next time, safe coding.
Safe coding.
Safe coding.
Take care.